Hey, you've probably already heard in high school physics that light is both a particle and a wave. Actually, we've been keeping something from you. Everything is a wave. Welcome to the duality of everything. So basically, back in the olden days, there were only two boxes that you could tick, right? There were either particles or waves. At first, everything seemed pretty clear, but then some experiments came and messed the whole thing up. There were a bunch of experiments that proved this two-box theory wrong, and the most important to me to tell you seemed like Thomas Young's double-slit experiment, which proved that light was interfering with itself, which meant that it was a wave, so check. And then Einstein and Planck had to work together a little bit to find out that light comes in little packets that we call photons. So particle. Physics was confused, so cue quantum mechanics. It's this new way to look at things. Throughout the old rule book, now everything's a wave function, but a wave. This is why photons, which are supposedly particles, can still interfere with themselves. I just want to be clear, classical physics could not explain this. So what's the difference between a particle and a wave? Waves can cancel each other out. The same can be said about particles. The problem is that we keep talking about particles because that's how they show up in our detectors, as little clicks in time and space. The wave is just a probability cloud telling us where that click is most likely to happen. If that's true, why don't I see my cat diffracting through my door? There is a simple answer to this. It's decoherence. Here's the deal.
First and foremost, a critical condition for interference is maintaining phase relationships of all the particles of the cat. The phase is like the timing of the wave's oscillation. Interference depends on those timings staying precisely coordinated. And with trillions of particles acting on the cat, air, photons, and vibrations, that's kind of hard to achieve. Secondly, everything has a de Broglie wavelength, equal to h over mv, meaning the bigger the mass, the smaller the wavelength. For an average cat, the de Broglie wavelength is about 10 to the power of minus 26 meters. So even if the cat could interfere with itself, the pattern would be too fine-grained to ever detect it.
That's why we have classical mechanics. It's a simplified but still accurate version of quantum mechanics on a larger scale. This is why for most things that we can see and interact with, like me throwing this pen on the table, we can forget about the wave behavior because it practically cancels out. So yeah, next time someone says particle, just make sure you know that it's physics slang for a quantum object that's a wave in disguise.